Well, we want to welcome you to the Kentucky Center for Mathematics. Today, we are going to be talking about the book, Developing Number Knowledge. Our very own Cindy Aossey. Cindy is a regional consultant with the Kentucky Center for Mathematics. And so, Cindy, I look forward to what you have to share with us.
Let me go ahead and open the app. Of course, my cat decided she needed to be let out at exactly this moment. So go ahead and open up the presentation. Okay. So I'm going to share my screen. And forgive me, I should have had some of this set up. Let's see, open up chat. So I will have chat open, so please feel free to communicate that way. Of course, always feel free to unmute and jump in and ask questions and share your experiences. I'm going to be talking about one of my favorite books, Developing Number Knowledge. There's my contact information that's available for you on the website and here in the handouts. But the book we're going to be talking about, as I said, Developing Number Knowledge, lead author is Dr. Robert Wright, and he is this driving force for a number of books. He is also one of the key developers of the U.S. Math Recovery Council, and Math Recovery actually is international, and he is actually located in Australia. So this is from 2018 conference, and I'm going to zoom in because we actually have a picture here of our three co-authors from the book together, Dr. David Ellemor-Collins, Pam Tabor, and Robert Wright. But I love having that full panel there because you get a sense that the authors are part of a big team and vibrant work that's happening both in the U.S. and internationally. This book is part of a series that many of you know. These all come from the math recovery work, and many of you know we tend to refer to them, the blue book, the purple book, the green book, to the point that many of us don't even actually know their titles. We just think of them in these, by their color names. So this is the red book and is part of that math recovery series. I want to give a little bit of history because I want to give you a sense of kind of when this book was written, and that plays into the big picture. So Dr. Wright, the lead author in that book, and if I back up, you'll see Dr. Wright is the common author for every one of these books. So his co-authors have changed, but he is lead author on every one of these books. And so 1993-94 is when he graduated and took position as working in Australia, Southern Cross University. But he was actually a graduate student under Les Steffi, who was the researcher who identified the stages of early arithmetic learning, the SEAL, and that work became a core component of math recovery. He worked with people in Australia, he worked with people in England, and he's even worked with people in the US here. And just to give you a sense of time, it was 2003 when the US Math Recovery Council was formed. So some of you may know, going back to KCM roots, and 2006 was when Math Recovery came to Kentucky, working with the Math Achievement Funds. And I share that because part of my personal journey was started around 2007, so very early in there. And our lead facilitators for that course were, let's see if I can get my pointer here, Kinsey and Petey MacCartey. And so you can imagine they were just 3 years into having this council when they were leading these courses here in Kentucky. So we were really part of some of this early work in math recovery. And some of that early work, in fact, math recovery, the AVMR courses, their first math recovery courses in AVMR were 2006. And just to put that in perspective, 2009 became a champion. So some of you who are in this meeting, you remember these early years. A lot of this was still forming and developing. Well, this isn't really a session about math recovery, but those roots matter. Many of you know the Red Book because you think of it as part of AVMR. Well, in course 1, which was 4 days, and I'm thinking back again in those early years, 2007, 8, 9, we did have the Purple Book. We had this 4-day course. Love the Purple Book. And we had a 2-day course for place value and multiplication and no book. But they kept saying, Dr. Wright is working on a new book. And I'll even kind of open that up. Some of you that kind of remember those years, and maybe you remember that with me. We spent years where Kurt or Petey or somebody else would talk about Dr. Wright is working on a new book. It's going to be in the Red Book. And there was just so much years of waiting for this book. And some of you now have taken course 2 and know that that book is an active piece of that course. But we didn't have it initially. So 2012 is when that book was published. And we were so excited, jumped in with book studies and readings, and it became a core piece of AVMR. And I gotta say, it was worth the wait. At least for me, it was this huge, it was like putting on glasses. It let me see further, and it let me see more clearly. And what I mean by that, the further was this book built on the ideas and philosophies of math recovery that lived in work for kindergarten, first grade, into second, and pushed it into solid second, into third, into that multiplication division work, into fraction work, into multi-digit place value work. So really took that learning, that thinking into the higher grades so we could see much further. But it also refined and really deepened some of the earlier work. There had been ideas that we just saw get polished in a very powerful way in this book. So I'm going to just pull out some highlights. We could spend so much time and there's so much to think about. But some things that are really critical in this book. They had this idea of themes of progressive mathematization, which is a mouthful, and we're going to talk a little bit about what that even means and what those themes are. There was this little snippet, this is like a page and a half in the book, about inquiry versus rehearsal mode, and I've got that as a handout for you in the packet, so we'll talk a little bit about that. But the bulk of the book is organized into 6 domains of instruction. So here we've got chapter. Each of these domains has a chapter. These are your instructional content areas. So number, words, and numerals. I'm thinking about reading numbers, forward and backward counting, you know, these foundations. We have structuring to 20. Structuring had already been a big piece, but I love, love, love their development here of really taking that to structuring to 20. Heavy work on the 2-row bead rack. Beautiful, beautiful second grade work. And into third, because we know students are still developing some of those understandings and that fluency. We have conceptual place value, and then tying that and being the foundation for addition and subtraction 100, pushing into that multiplication division in a wonderful way, and formalizing that mathematics with written computation. So each of those instructional areas gets a chapter. There's theoretical, big picture ideas in the overview. We see little vignettes of how students might be reasoning and what to look for. We have discussions of instruction. And then we have assessment tasks, so how to interview students and what we're looking for in those interviews, and then instructional tasks. And great resources for the instruction, including that CD that has those printables ready to go. So let's back up and dig into some of these pieces. Themes of progressive mathematization. So I'm going to leave this sentence up here for a moment and just give you a moment to read through this definition. So one of the things that's important in math recovery is we always, and just good instruction, I think all good mathematics instruction recognizes this, is that it's about the student's understanding. We're digging deep. Yeah, it's over time. We have to have student understanding of what's happening, and the student becomes more sophisticated in their reasoning. And so there's a lot of dimensions, or they use the word themes in here, about ways students build their sophistication. So they identified these 8 themes. One thing I did want to point out is I have a link up here. So if you don't have the red book, I would love for you to go check out this link. It's an ordering site, but they do have a sample of quite a few pages from the book, so you can read most of the first chapter or so. And it actually includes almost all of these themes. So if you're just curious and want to dabble in the book and don't have it yet, it has the overview and themes A through G, I think. It goes through like page 18. So it can give you a pretty good exploration of these concepts. And it's really just a couple paragraphs on each theme, but the themes then are woven into the instructional. So we see these themes developed as how they relate to those content areas as we dig into the book. And I gotta tell you, but kind of this was a mind-blown moment to really think about all these different ways kids build their sophistication in mathematical reasoning. They structure numbers, and okay, what does that mean? You know, looking at numbers as being composed of smaller pieces, being able to decompose and compose numbers and use that to fluently add and subtract. Kids that work with bigger numbers, they think about the base 10 units. There's all these really beautiful and sophisticated ideas going on in here. And one of the things I want to point out is I gave you that history to show how this red book happened in a journey. Well, that journey hasn't stopped. So David Ellemor-Collins and Dr. Wright have continued to collaborate and have come out with the white book since then. And I should have looked it up, but they kind of took these themes and got even deeper into them with more themes and partitioning that even more. So they've continued that research. So if you're interested in that, you might want to check out that white book and see how they go even further with it. I actually really love the red book organization and how they broke it up in that book. And I could have picked any one of these to talk about. We couldn't do all of them. And just settled on notating because I thought there were some interesting ideas for us to pull out in here. So in notating, they make the point that we're developing students' understandings of mathematical concepts, but that mathematical notation has to underlie, concepts have to underlie the mathematical notations, but making sense of mathematical notation and using and having that tool that writing gives kids deepens their understanding of the concepts. So they make the point that these things are learned in tandem. It's not one then the other. It is that concepts underlie notation, but notation can deepen understanding of concepts. And I thought we could just take a couple examples and look at that together. This one actually comes straight from the book. And they talk about, you know, a really good exploration should happen, you know, in every 3rd or 4th grade classroom. Find the factor pairs of 24. Maybe it's posed more in a sort of context of saying, what rectangles can you make with 24 squares? And students are doing their exploration and they might come up with a variety of answers. And that's perfect. They need to. They're developing a concept. But if we just leave it there, we haven't really optimized the learning. So they make this example that we could take that work where they're finding those factor pairs and as a teacher, organize their thinking into just this list, just simply this list. And they said, so how does having that notation now? So we took that student work, that conceptual understanding, and we organized and used notation to describe it. Why? What will that deepen in the student's understanding? So Amy, you're talking like making connections. Some people have the book. So I want to take a moment, like why? Why would that be helpful? What conceptual understandings can be strengthened by just taking that time to list those factor pairs and reflect on the numerical representation? So you can chat, you can unmute. What kinds of things might that help a student? How might it help deepen a student's conceptual understanding?
I think it helps them understand multiplication, what it means, and the meaning of factors, and it provides a visual because when you list 24 factors, you move beyond addition, seeing numbers in additive. So I think it really gives this in-depth understanding of what multiplication really does to numbers.
Yeah, I think so. You might want to add to that. Okay, Lucy, how to build on a known fact. Right, you're seeing now that organization might really help kids see that relationship between the 1 by 24 to the 2 by 12, sort of that doubling and halving, or some of those other relationships. So the organization, you know, Funda's pointing out, helps them recognize, and I think you hinted at sort of this, that it's a recording. It's a way of recording what's going on with those visual models. And so we see the interconnectedness. I love that word, Kelly. And so they just point out, I think you guys were capturing this. One of the important things is recognizing that a multiplication expression, like 2 times 12, actually describes something and isn't a problem to be solved, especially not in this case. We already know the answer. We know the 24. The point of writing 2 times 12 here is to communicate that situation of a 2 by 12 rectangle, and the 3 times 8 is a 3 by 8 rectangle, so that an expression shows a structure and isn't a problem to solve. That there's relationships between pairs, even just the organization. Have we found all the rectangles? Might be hard to know that if I'm working on graph paper, but we can probably convince ourselves that we've tested for all the possibilities, barring, of course, commutative property. We could do the 6 times 4 and the 8 times 3. And it just gives us an example of how that discussion can go and how deepening the conceptual understanding comes from the notation. Lots of things there. I won't go as deep with this example. And of course, my cat chose to join us right now, so I apologize if you can hear her in the background. Many of us will work with 2-digit addition. We might pose that addition problem with 10 frames. And ideally, we'll probably put up that image and then maybe screen it and be having the kids really internalize what did they see, and they give us verbal explanations. So think fairly classic number talk. So in that number talk, we showed that image. I'm going to go ahead and leave it up here for us to talk about as educators and think about, you know, students might say something like 24 and 10 is 34, 2 more is 36. So they're attending, attending to, or keeping that 24 whole and incrementing by a 10 and 2 more. So as a teacher, I've got all these choices about how I can annotate and how I can record that thinking. And we can't really even go into it all. But one of my ways I might go would be very linearly. How can I connect that to a number line? And how does that number line notation deepen their understanding? I might connect it to something linear that has a little quantity to it. So putting it on what we tend to refer to as a quantity line. EAI sells this dry erase number line that looks like this red and white with the boxes model. I might do it on a 100 bead string or bead bar. So I might do something that connects it to quantity and but puts it in a linear setting. Or, and this actually comes directly from the Red Book, I might use an arrow notation to really emphasize this idea of I land on. So 24 and 10 more land on that 34. And then when I add 2 more, I land on that 36. It gets me to the 36. I do want to caution, and this is a conversation we often have in our sessions, about the appropriateness of using the equal sign. So the arrow gives a nice way of capturing that action. If we want to use equal sign, and certainly there are times when I do, just be really cautious that we make sure our equivalencies are used correctly, like in the bottom box. 24 plus 10 gets me to 34. New sentence. Now that 34 plus 2 equals 36. Lots of different choices there. They both deepen the understanding, but they're also going to become tools that the kids to work with more complicated problems. Now, a student might say something completely different. They might have chunked those 10s. So the 20 and 10 is 30, the 4 and the 2 is 6, so I have 36. I might start by recording that with the materials. And somebody pointed out, you know, using other base 10 materials. Absolutely, I could do the exact same thing with bundles and sticks. There's so many amazing visuals for base 10, and I would encourage you to do that. But in terms of the strategy, we think about those 10s to 10s, 1s to 1s. So now my notation can be different. Now I might think about using that sort of splitting notation to show how I decompose the 24 and decompose the 12. Might even use some color to help kids really connect parts to part. That's probably a very early recording, just starting to see how numbers can capture what's going on, versus something that's much more column oriented. We definitely want to start moving to this notation where students are seeing that that 2 for the 20, the 1 for the 12, I'm sorry, the 1, 10, and the 12 makes the 30, and the 4 and the 2 make the 6. So students are starting to see that that columns, the place value does live in columns, and we can use those columns for efficient adding, and ultimately take that to the algorithm. So the algorithm basically becomes just a streamlined recording of the thinking they've already had. The notation deepens the conceptual understanding and it refines it and takes kids further. So these things work in tandem. And it's a balancing act for a teacher, right? And you guys have danced this line in your careers. You're thinking about, how do I build those conceptual understandings? How do I make choices about recording? If we go too fast, we just jump straight into that recording, it's disconnected from ideas, and students start thinking it's this syntactical game. I love that phrase. I hate for it to happen, but I think that phrase is a good explanation of what does happen for so many kids, that when we only lived in notation, it became this arbitrary set of rules. But we also want to acknowledge the strength of notation. Done well, done just in time, it captures the student thinking and refines it. Again, one theme. This is about 3 paragraphs, but then it lives in the units, and we see it applied to structure into 20. We see it applied to conceptual place value and so on. And beautiful, beautiful ideas throughout here. I'm not going to spend too long on inquiry versus rehearsal mode, because you do have this particular page as a handout. It comes fairly straight from the book, and I'm going to zoom in on that chart. But what this discussion is about is finding that balance in our classroom between activities that we think of as inquiries. So these are going to be very challenging for the students. Their process for solving it isn't going to be clear cut. We're going to see kids needing a lot of autonomy, time to explore, time to talk to each other. There's going to be this sort of ebb and flow as kids puzzle things out. And then rehearsal mode comes when tasks are becoming routine, when they're pretty clear on the process, but they're needing to build their speed and fluency. These are great, when you're at that game point where we just want to get those, say, combinations to 10 solidified and just really solid, and something I can use for other work, when I need those skills to be solid and something I can build on. So the pace is brisk. And, at the end of playing the game, we might have a good conversation about what 1 or 2 facts or what 1 or 2 questions in the game did cause difficulty. What could we do to work on those for next time? But most of the time when I'm in rehearsal mode, things have that fairly brisk pace. Students feel confident, but they're continually getting checked on their work so they know their accuracy. And they talk about kids need a steady diet of both. And I love that language, that steady diet of both. And they acknowledge the difficulty, because the same question might be inquiry mode for one student and rehearsal mode for another in the same classroom. Or you can also think about it that for a student, what's an inquiry mode question one day, 2 weeks later is rehearsal mode. So it is something a teacher has to also be observing for these characteristics to know, are kids like exploring this concept or rehearsing this idea? So that's just a touch on inquiry rehearsal mode, and you do have that in your packet. And then the final domain, I wanted to dig into the domains. This is the meat of the book, where you have each of these chapters exploring beautiful ideas. And mostly I want to dig into that conceptual place value one, but it flows a little bit, or it flows into that addition, subtraction to 100. Again, each of these chapters has that overview, has the assessment tasks, that should have been plural, assessment tasks, lots of questions we can be asking kids how they're thinking, and instructional tasks complete with resources. So I'm going to tell you, before the Red Book, we kept using this phrase, conceptual place value. And I kind of had this like, I guess it means they get it, but I didn't really have a definition more than they understand place value. but it really wasn't clear, at least in my mind, in the early years, like before the book, like what that really meant. And so I love this chapter. I continue to suggest teachers dig into it, because there's this amazing sentence here at the beginning of chapter 5 that defines conceptual place value. Saying being able to flexibly increment or decrement by ones or tens, later by hundreds, is critical knowledge for developing facile mental computation. So this is an essential skill. And then the skill is what they refer to as conceptual place value. And I thought at first that was just strange to me, that a skill was conceptual understanding. But then I watched kids and I thought about what they really meant. And from the earliest, I think about our early K students counting, and I actually love it. And kind of give me a thumbs up if you've heard kids do something like this, where they're counting and they're starting to really tune into the pattern of the numbers. And they're 28, 29, 2010. And they're like, wait, no, there's no 2010, it's 30. Think about the understandings that are going into that. We're starting to see the pattern. We're starting to hear that 20 plus and how the ones numbers increment by 1 each time. And all of a sudden we have this, but wait, I made a 10, I have to go to the next decade family. That's where they're building their understanding of place value. Doing the same thing with materials, right? I start with 27. First, how do I count those bundles and sticks in front of me? Do they know to count that as 10, 20, 21, 22, 23, and so on? Or even do they recognize 2 bundles and 7 loose sticks and put together as 27? Certainly we see some, in early stages, simply counting that, and some are counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, they're not seeing a bundle as different than a stick. Or 10, 20, 30, 40, 50, and not transitioning to counting by ones, when they move to the sticks. So first, there's just counting that, and it's huge. But then, once I've established that that's 27, do I recognize 10 more as 37, 38, 39, 30, 10? Same idea as kindergarten, in those counters, but realizing it again with quantity. How do I handle those 10 loose ones and realize I have 40? Huge idea. Exactly, Amy. This is such an incredibly important skill we can be developing in first grade, is simply counting with those sticks and bundles. And how do I go from that 40 to that 50? And knowing I can increment as a 10, where some kids are going to start off by going 40 and then 41, 42, 43, 44, so they're building understanding of place value as they think about how to add that chunk, add that 1, add that 10, or possibly 100. I did want to point out there is a link down here at the bottom. Sorry, my screen just covered it up. And that'll take you to where you can get all these clipboard images. So now that we're kind of in our remote teaching, that is a really handy site to be able to have that clipboard. Getting a little bit behind here, so I'll just kind of note that this is here. Same things happen when we work with hundreds, tens, and ones, right? Kids need to be able to think about what's going up as increased by a 10, increased by a 1, increased by 100, and so on. And what we're doing forward, we should do backwards. So I should also be giving them sticks and bundles or 10 frame representations and thinking about what happens if I take away a 10, what happens if I take away 100, and really just focusing in on this counting where the students just handle a single chunk of 1, 10, or 100. And then seeing how that 258 as a numeral connects back to all those quantities. I have those 200s, I have those 5 10s, I have those 8 1s. This comes from the Red Book, and just such a great activity as we think about that notation starting to formalize. Kids have experiences with hundreds chart. Hundreds charts are fabulous, but we don't want them to become a crutch. We want them to actually be a setting for exploring ideas. Students should be able to create that hundreds chart because they understand the patterns. And often we have them fill in complete hundreds charts, but I love having them think about filling in part of a hundreds chart. And so you're seeing that, thinking about like little Tetris strips. Absolutely. And I can put any number into there. And I won't take too long with this, but I did set up just like a Jamboard. So if I'm thinking about doing this more in a virtual environment, just cut and paste that image, and now it becomes something we can record on, because I want to give you some examples of things that we might use here. Because I also wanted to mention, don't be afraid to go kind of outside the traditional range of a hundreds chart, right? Go ahead and have them think about, if this is 87, right? I have my 88, then I have my 98. Oh, now how do I cross into that hundreds family? You know, I have to think about how that's 108 and how that's 118. Really sophisticated reasoning going on in there. And so you do have this printout in your packet. The 42 is put into the first one, but use these strips however you want. And what we do forward, we can do backwards. So what does it mean to go back one? What does it mean to go back a 10? Obviously, kids would have to have had some experience with a hundreds chart for this setting to make sense. But once they have a sense of the structure of a hundreds chart, then these puzzles become a great way to practice. Yep, or I could zoom in and play around with not necessarily filling the whole chart in, but can I just fill in and anticipate? And so verbally think about, here's 65, here's 75, here's 76. And so all they need to write in is that one number that I've circled there. So there's all sorts of possibilities of puzzles you can generate, and that particular activity is in your packet. So this idea of being able to increment tens and ones, which at first sounds like they're describing a skill, is really conceptual understanding. Students become proficient. And by doing so, they're dealing with numbers in their entirety. So they think about like 364. Yeah, they're starting to recognize there's a 300 and a 60 and a 4. But more than that, they're thinking of 364 as a single whole that has a relative size that's smaller than 365, that's a lot smaller than 465. So they're getting a sense of numbers and their magnitudes. They're starting to decimalize. That means thinking about those base 10 units inside the numbers. Conceptual place value is critical. Many of you are talking about these activities in first grade. That's right, it does. It starts in first grade. And so these are exactly the experiences we want in first grade. We build on those and keep them up in second grade, and we build on those, and it's really not until fourth grade that we're really living in conventional place value. This is really where we are focused very much on the role of the digits and what place they're in, and decomposing and composing those numbers that they build. So we do want kids to be able to work with the numbers and their positions and have those understandings, but we see this growth over time. Just hinting at some other things in the book. As we get into the next chapter, we build on that conceptual place value to get into robust addition, subtraction of 100. And one of the things that was new for me in the Red Book was this idea of phases of instruction, that we can chunk the instruction into like this body of knowledge is developed in phase 1. And then in phase 2, we're going to start formalizing it and developing strategies. You can see the role of notation, flashing back to our theme, that notation is critical to developing those strategies. And these posters, by the way, just came from like when I was in a course and we did a poster jigsaw with the phases of instruction. And then phase 3, how do we really extend on that? So students have strategies of splitting and jumping, but we can take it now to 3 and 4-digit numbers. We can solve more sophisticated tasks like missing addend or missing subtrahend. We can have more open-ended questions like what are ways I can decompose 100? So that happens in that phase 3. So these phases of instruction was a piece I really loved in the Red Book. Again, printables for activities. When students are in rehearsal mode for addition, subtraction, we've got centers for them to be doing that work coming straight from the book. So awesome resources for each of these strands. I had a hard time picking which chapters I wanted to look at because structuring the 1 to 20 chapter is a really, really, really close second to me. But the conceptual place value chapter, I have to admit, is my favorite. So this body of knowledge is continuing to grow, to continue to be shared. There's a vibrant community. So these were photos from the 2018 conference. We have Dr. Wright, Dr. Ellemor-Collins, Pam is there with our RC Lisa Riggs, and Jim Martlin's jumped in there, who is one of the authors in couple of the earlier math recovery books. That community is still working together and learning and growing this knowledge. And I leave you with this quote that reminds us of what our purpose of teaching mathematics. It's about the students, about developing their understanding, and we give them opportunities to problem solve, to visualize, to organize and justify and generalize. We'll hope you'll come back and join us for more KCM favorites. Looking ahead, we've got Bonnie on Thursday sharing math fact fluency, and Friday we're taking a look at a high school resource that I personally am very excited to hear about.
As always, from the Kentucky Center for Mathematics, we want to thank you, Cindy. Your exuberance with regards to that book has me anxious to prop up in my chair tonight to revisit some chapters. It was fun seeing those of you that were in the chat and those of you that were on Facebook reminding us of the journey that you've had with the Kentucky Center for Mathematics. So this is the time that we give Cindy some props. She worked diligently to try to put such a big book into 30 minutes. And so
35.
You got it. Stacey Jones says she thinks that she hasn't dug into the book for a while, and thank you for reminding her about things that are important. Indeed, Funda says that she loves seeing that comprehensive perspective that you provide in the book.
I have a question, and maybe not just directly at Cindy, and then I'm going to have to go. I have a student in about 10 minutes here. The CD is wonderful, and I have a CD-ROM on my work computer, but if I only had the book at my home, I don't always have a computer with the CD-ROM. Are they going to come out with, like the purple book, you can go online and, you know, look at all those resources that would have been on the CD. Does anyone know if they're going to change that at some point?
I haven't seen indication that they are. I do know that you can copy the files off of the CD-ROM.
Okay.
I've been able to transfer them to my computer and say put them in Dropbox so people can have access to their copies of the files if they have the CD-ROM by doing that.
Okay.
So exciting to have all of those great resources there. Cindy, I think you highlighted again the importance of place value in really conceptual understanding, and how funny that was that you gravitate toward that subject. So at the Kentucky Center for Mathematics, we are here every afternoon at 2 o'clock with a variety of content. We have quite a group of folks that continue to join us, and so we thank you so much for joining us every afternoon at 2 o'clock. Tomorrow, we'll see you for Math Fact Fluency. Thank you. See you.